Thank you for joining and a warm welcome to our very first webinar about our new Carbon Mines Lifecycle Assessment database for chemicals and plastics called cm.chemicals. We are very excited to have you here today for this year almost premiere, you could say, where we are introducing the new database for the very first time. And before we jump into the agenda, I would like to introduce the people whose faces you will be seeing in the next hour, and starting with myself. My name is Mara Buitz, and I'm coordinating the marketing and communication activities at Carbon Mines, and I'm very happy to take over the role as moderator today. Next, I would like to introduce Raul Mais. Raul is one of Carbon Mines' managing directors and founders, and then he has background in chemical engineering and experience in leading an LCA team at RWTH Aachen University. And he is currently responsible for the technical development at Carbon Mines. And the third face you see here is here on the slide is Arne Ketelhöhn. He is our other managing director and founder of Carbon Mines, and he was also leading an LCA team at Aachen University, where he and Raul met for the first time and set the foundation for, the startup that is now Carbon Mines. And he worked in several positions related to environmental assessment in the US and China. And now that you know a little bit about us, we will jump straight to the agenda. So today we will be touching on the topics of general information about the new database and what it covers, give you some background about its methodology, such as how our data can improve the insights gained from your lifecycle assessment studies in different use cases, and also very importantly, how to get cm.chemicals in your software and ultimately use it. And in case you have any question pops up in your head during the webinar, please feel free to write them directly into the chat at any time so we can address them in the Q&A sessions. So we will be having, we will answer some of those questions during the presentation around halfway in, and we have one other Q&A session at the end of the webinar. So please just pop them in to the chat directly when they come up. Yeah, and without further ado, I would like to hand over to Raul to start with the presentation.
Okay, thanks Mara for the kind introduction and also a warm welcome from my side. I would like, before I start going into the details of our modeling, I would like to start with a little bit of introduction of Carbon Mines, who we are, what we do, and what our overall goal is. So what we basically do are three pillars in our company. First of all, we do data. We made the lifecycle inventory database, of which we will see a lot of details today. But we don't do only data. We also do analysis and consulting, which means that we even go a step further and also include environmental assessments of individual suppliers or entire markets, all related and based on our very sophisticated database. Finally, if you know how to basically assess current situation based on the current chemical and plastics industry, we like to do also consulting services in the area of the low carbon transition. So basically pathways towards a more sustainable and less emission intensive chemical and plastics industry. We have a very strong already existing network with the chemical industry. We work with Covestro, Evonik, Cura, Lanxess and more, but also with industry associations. And for the people from Germany, the DECHEMA is one of the largest industry associations for biochemicals and the chemical industry. And we work with all of them. However, the core of our company is data. And here, that's the reason why we are here in our webinar, is the cm.chemicals database. And this new inventory database for chemicals and plastics comes with three major advantages, which I would like to tell you directly before starting with the details. And first of all, we have a very broad coverage. We have many, many data sets over 45,000 datasets with covering around 1,000 chemicals. We are highly regionalized, and I think that's even a one more important advantage, which we are going to see more information later on. We have over 190 production regions, or up to 190 production regions per chemical. So we have a large regional coverage. And what I'm also very proud of is the third advantage of our database. Our methodology has recently, mid of September, end of October, been certified by the TÜV Rheinland, a very big certification agency here in Germany, but also internationally operating, to be in compliance with the ISO 14040 and 14044. If we now want to understand why we are actually able to do these big novelty, to make this big new lifecycle inventory database, we first have to understand how the chemical industry actually work. And for this, let me just briefly introduce the basics of the chemical industry. And to do that modeling and all the details, we basically need 3 input data to generate everything I showed you. First of all, what we need to do is we have to know the production location and the volumes of the chemicals. So we have to know where which chemical is produced. But we have to go a little bit deeper. We have to additionally know where which chemical is produced, with which technology and with which process parameters, which unit operations are used. And there are many in the chemical industry. And finally, chemicals are treated globally. So we will have to need to take into account the international trade between each and every producing regions of chemicals and plastics. And that's basically what we did. But in contrast of all other databases and all other modeling approaches, we start at a different detailed level. We start at a plant level and a production site level for chemicals and plastics. And in a simplified manner, you can think about that, that we first take a look at all plants producing chemicals on the world. We take the installed plant capacities, the production volumes, and the respective technologies. Just imagine 3 plants, plant A, B, C, producing different chemicals. The second step is we aggregate these plants to production sites like Ludwigshafen, Rotterdam, Antwerp, maybe Houston, and other regions in the world. Based on this aggregation, we can already make mixes of technologies in a site that produce the same chemical product. So we are already able to identify the mixtures on a very detailed level. But now, as we are all doing life cycle assessment, we know that to provide a carbon footprint or any other environmental impact, not only the production technologies, but the complete supply chain is important. And here we make in our database one important assumption, because we take a look at the plants and the consumption of raw materials, and then we basically say that in a production site, so an integrated production site, it's more likely that the plants B and C will consume the raw material, which is first of all produced on site at the same site by plant A, for example. Our studies and the discussions with industry actually confirmed this, our reasoning that it's more likely to not transport the chemicals all around the globe, which is also done in the chemical industry. And but it was confirmed in our discussions with our partners. However, not everything is can be produced in the site. So you will always have to get some raw material from outside your system boundary of your production site. And this basically comes from the national consumption mixes. So what we did for all the plants and all the production sites, we did not only have to do for one, but we had to do that for each and every production site for a particular country. And you can imagine that there are several sites, site B and site A, who produce the same chemical with different technologies. And these different technologies producing the same chemicals in our assessment are then combined in the so-called production mix. This production mix then supplies the consumption, and the consumption then exports and imports the same chemical materials from other regions. So for one chemical, we had to do that for a single country, but also for all other countries with all sites and all different production and consumption mixes in our assessment. And what you can already see on that picture is our key advantage, because if we take a look at all the different plants and our consistent model, we can even go a step deeper and aggregate, filter our data sets, for instance, for a particular supplier. Or we can make a data set also for a particular site, for a particular technology. So due to our basically foundation and bottom-up model of the chemical industry, we are very flexible in the analysis and the data sets that we can provide to our customers. This model, the theoretical model, is currently implemented in a large computational structure. We basically take the input data, which I showed you, the production locations and the volumes of the chemicals, the technologies and the international trade flows, basically include them via MATLAB, Python scripts in a computer model of the chemical industry, which is why we are also able to back calculate all values from the past to the current situation, and why we can update the complete databases each and every year without any problems, because the routines are completely automated. So there's no like manual making of each and every connections. But we are also able to include customer data. If someone, for instance, would say, we buy from that supplier, we could also include that. From that model, we then extract the cm.chemicals database data sets, which we're going to see later. The complete workflow, so from input data over the inventory model of the chemical industry to the cm.chemicals database, includes annual updates and is also surveilled each and every year by third party like the TÜV Rheinland. And before we now go a little bit deeper into the different data sets and the case study, I would like to ask Mara again if there are any questions at that point that might be already answered, and the rest will then be taken later.
Yeah, awesome. Thanks, Raul. I'm just looking at the chat and see if we have any questions. Yeah, grabbing the first one for you to answer. Are the data sets like a black box, or can they be modified for energy consumption grid mixes, or is that an additional charge on top of the full database?
That's a very important. Yeah, that's a very important question, and it's also a very clear one. So currently, we only provide system and aggregated data sets. So basically, no unit processes like some of you might be used from EcoInvent. But if it's needed, we are open to provide sort of a contribution analysis inside the discussion with our customers. But that's something that is a case by case thing.
All right, thank you. Now coming to the second one, are all your chemical data sets calculated based on primary data from production sites, or do you use reference databases like Gavi or EcoInvent?
That's also a very, very good question that goes a bit to our background data sets that we use. So what we basically do is we make the complete model based on partly secondary, partly primary data. So the primary data basically lies in the production locations and the plants where they operate, because that is based on the reporting of the companies. They say, I operate a steam cracker using naphtha in Rotterdam or Antwerp, right? So that's kind of primary data. The technology data, so the mass and energy balances with for all the technologies, so inputs and outputs of that steam cracker in Antwerp, they are based on secondary data and very sophisticated modeling approaches. And for the chemical engineers here, it's a very sophisticated Aspen or ChemCAD simulation that's in the background. And the results of that simulation has been verified with the actual industry partners who build steam crackers. Not always the operators, but the one who builds the plants. So we have sort of a verification step within the background data we use and license.
All right, awesome, thanks. Maybe just getting one more question. The yields efficiency and the energy consumption is normally not communicated by chemical producers. Where did you get the data from?
Yeah, that's maybe something similar that what I just answered is the energy consumption and the modeling is based on secondary data, very sophisticated modeling approaches based on the industry standard data that everybody in the chemical industry is basically using and which is established. So we use state-of-the-art background databases for these mass and energy balances and the simulations in Aspen and ChemCut and all the other solutions that are on the market.
All right, and then just making one more before we move on. How long does it take to include a new material in the database?
It depends. How good is the data that someone could provide to us? It depends a little bit. So for instance, let's say for the steam crackers, it took really long because there are so many operating. If you are, for instance, in the fine chemical business and there are only 4 producers globally, and the simulation data and the secondary data for the mass and energy balances is there, then it would be relatively easy to include these 5 operating plants. If we know where they operate, if we know how much they produce, if we know which technologies they use. But if someone would provide that to us, it's fairly easy to include new chemicals. The time, I can say, it really depends on the case of the chemical, the data that's given to us or that we have to derive.
All right, awesome. Yeah, thanks, Raul. We have a couple more questions, but I think we should continue with the presentation first and keep those ones for the end. And just to give you some information to all the ones who ask the questions, we will also be putting them all in a Word document and send it to you afterwards with the answers. And we have also some more time to write them down for you. All right,
good.
Thanks, Raul. We'll continue with the presentation now. Arne, the stage is yours.
Great. Thanks so much, Mara, and hi everyone, also from my side. So now that we looked into the database methodology, I think it's time to jump basically into the data that you can get out of this database and see what kind of data is really available there. And in principle, there are 3 types of data sets that you can get in the cm.chemicals database. And if you remember the flow sheets that Raul showed you already saw these types of data sets. Those are technologies, those are production mixes, and consumption mixes. So what does it mean? Let's look at them one by one and start with the technologies. The technology data set is a lifecycle inventory data set, so basically an LCA data set based on which you can calculate the environmental impacts, many different environmental impact category of an average product unit produced with a specific technology. So for example, in a country or in a region. Why is this important? Well, the reason is we have many different chemicals, but all the different chemicals, they can be produced using different production pathways, using different technologies, yeah? And the environmental performance can be super different. I brought the example of methanol here, which I'm going to use pretty much throughout the entire presentation. And if we take methanol as an example, there are 4 types of technologies that really produce on a large scale in the world. It's steam methane reforming of natural gas. It's gasification of coal. Coke oven gas utilization and gasification of heavy fuel oils. And what you see in this diagram, basically the global production shares of all the plants in the world. Yeah, so pretty large scale. What is important to understand is the picture looks really different on a local level. So, for example, gasification of heavy fuel oil is mainly used in Germany. And there's, I think, only one other plant in Russia that uses this technology. Gasification of coal is largely used in China, and the same goes for coke oven gas. Yeah? So this picture changes a lot. In technology data sets, they now don't look at these mixes, they look at every single technology individually. And this is important simply because the technologies, they are just very different. I took the most commonly used methanol production technologies here as an example, gasification of coal and steam methane reforming of natural gas. And what you can see directly from this flow sheet, the technologies, they use different feedstocks. They need completely different production steps. These production steps, they have different energy demands. They produce different types and amounts of waste and emissions. And this, even though the methanol that is coming out in the end, it's both methanol. But of course, environmental performance is just very different. So if we take the climate impact as an example and look into the global average carbon footprint, in kilogram CO2 equivalent emissions per kilogram of product, then we can see right away, whoa, coal gasification, this has really a substantially larger climate impact compared to steam methane reforming. So if you know where what technology is used to produce your input, choose the right technology. This makes really a difference. What we also need to keep in mind, there's not an impact per technology. This also changes a lot regionally and also depending on the integrated production side. So there are potentially large regional differences, and the impact of these technologies, it of course depends on the plant-specific supply chains. Maybe just a quick disclaimer. I'm going to talk a lot about methanol and also about climate impacts in my slides. Not because I think methanol is the best chemical or climate impacts are the only important impact category. Of course, all environmental impact categories are important. All environmental impact categories are covered by this database. It's really just an example here. And in this case, it was an example for a technology mix. So why should you use it? Well, the benefit is really that using technology-specific data, it just makes your LCA study more representative and more accurate for the situation that you are specifically modeling. And this is what you can get from this database. You can get technology-specific data. And for some of the chemicals, we really have more than 20 different production technologies for exactly the same technology. And this is represented by these technology data sets. Yeah, this was the first type of data sets that you can get from the data database. What else do we have? We have production mixes. So what is a production mix? A production mix is a life cycle inventory data set based on which you can calculate the environmental impact of an average product unit produced in a country or in a region. Yeah, so here we're really looking only into the local production and the different production mixes. Using the example of methanol again, you can see in this world map there are quite a number of countries that are producing methanol, and the shade of these this color here, it corresponds to the product carbon footprint between 0.5 and 3.2 almost. So there are quite some differences in the average production emissions. So when I talk to LCA practitioners, sometimes I get asked, well, why don't we just use the global average? Chemical is a chemical. Let's use the global average. And this is something I really don't recommend. And let me show you why. So let's imagine we would take the global average in this situation. It's 2.1 kilogram of CO2 equivalent emissions. Okay. Then someone might say, well, it doesn't have to be the global average. Let's get a bit more specific. Let's take a regional average, like a European data set or an Asian data set. Okay, if we do this, we will again see, okay, we get more specific and the value change. In this case, for the example of Asia, it would be 2.8 kilogram of CO2 equivalent per kilogram of product. So it's already quite a bit different when we move away from global to a more specific average. But zooming in further, we can see that also large regional average, they are really not necessarily representative of the country. So imagine you're doing a study where the supplier comes from India, then the average production mix would be 0.7. Yeah. So if it's an important raw material, you can easily get an error of a factor 4 into your LCA studies by using two rough regional averages. And this is why this regionalization is just super important, and it's especially important in the chemical industry, where we can have very different production chains depending on the country. Yeah, and again, the benefit here is if you have this data, and we have more than 190 countries and like real regionalization throughout the production mixes along the entire supply chain. This will again help you make your LCA study better and more representative. And this was the introduction of the production mixes. One type of data set is left, and this is consumption mixes. So why do we need this in addition? So again, the formal definition, it's an LCI data set based on which you can calculate the environmental impacts of an average product unit, in this case not produced, but consumed in a country or a region. Why does it make a difference? Well, if we consume something in a region, it could be produced locally, or it could be imported from other countries. And I made just a small visualization here. So I'm moving backward between the picture of the production mix and the consumption mix. And we could see there are just many more countries in the consumption mixes. And all those countries that fade out in the production mix, but are there in the consumption mix, those are countries that don't produce methanol, but only imported from different regions. And this is why we have more countries here. But how much difference does this make? To explain this, I just brought an example, and it's an example of methanol production in Germany. It's a small country in the middle there. And Germany is, of course, a big methanol producer, but also a big methanol importer. So about 50% of the methanol used here are also produced in Germany, while the other around 50% are imported from 20 to 30 different countries. So for example, Netherlands, Norway, Belgium, many other countries. Some of these countries are also trader. So for example, Netherlands is so big because they have the huge harbor in Rotterdam, and sometimes the methanol, or really the methanol, gets traded through Rotterdam before it reaches Germany. So as you can imagine, the consumption mix, it will depend on the emission intensity of the regions where you import from. And this really makes a difference. So if you take this as an example, consumption mix, carbon footprint would be around 1.5. And if we now compare this with the production mix, it's much higher, simply because the German production, you remember, they have a heavy fuel gasification, is just more emission intensive than the average of these imports. And this shows the importance of trade. And this trade, of course, it doesn't happen only at the last stage. It happens at your tier 1 and tier 2, tier 3, tier 4. So throughout the entire supply chain. This is nothing that you can simply implement at the end as a practitioner. So this is why we included this in the database. And by this means you really have a database where there's a detailed trade model in the background. And I think the scope and these types, those are really big differentiators of our database. But there's one more missing, and maybe even one of the most important one, and this is the quality assurance. So databases are huge, and of course we could stop here and basically tell you it's an amazing database. But databases, they are so big, it will be I would say impossible for you to really see assess the quality yourself. So we don't just want to self-declare our quality, we want to prove it. And this is why we went through a very detailed review process with one of the hugest certification companies, to Rhineland, where they reviewed our methodology for ISO compliance, where they looked into our data to check the data quality indicators, so that this is like really transparent for you. And what is important, we don't do this just one time and then stop with it, and you will never hear from it again. We do this every single year. so that also all the updates will be reviewed. One type of quality assurance, and the other type you saw in the beginning, we're a spin-off of Aachen University. We come from academia. We do publications, and we were lucky enough to publish a paper in Science this month, I guess, last month, or earlier in PNAS. And those of you in academia, it's not super easy to get into this journal. So there's also quite some peer review, not of the entire database in the end, but of the paper, the part that is used there. And this is the quality assurance part. I think there's just one last question left that I would like to answer before we get into the Q&A session. And this is, if you are interested in the data, how can you get it? And the answer is we have, first of all, data packages for our database, and we have so-called data on demand. So data packages, they cover the most important chemicals, and it's one package, you get all of them. And data on demand, there you can go on our website, search, and buy or license only the ones that you really need. The data packages, they are three. All of them include the 78 most commonly used chemicals. The basic package has only production and consumption natures and the main chemical production regions. Technology Insights package also has the same scope, but adds the major production technology. And the Global Insight package, it has a full geographical scope, so basically all the countries that are covered for these chemicals. What is nice for you, that it's convenient to use it because it's in many different software tools. So almost all of the major LCA software tools, it's available in CIMA Pro, in OpenLCA, Umberto. You can use it in Brightway. And what is nice is we have a really good collaboration with the software providers. For the first three, you can get it directly from these software providers due to our collaboration there. For Brightway, just go via our website, and we're happy to help you. And also, if you need a different data format or maybe a larger scope, for example, the entire database for portfolio-wide automated assessment. And these are database packages. The other thing I mentioned, yeah, prices maybe also important before we go to data on demand. Of course, I can't talk about or for our resellers on the prices, but I can say what the databases base packages cost at Carbon Mines. And the prices, they range from 1,000 to 5,000 euros for a user license, an annual user license, basically. And if you're coming from an academic institution, you can take one of our educational licenses, which is 50% off the price of the commercial licenses. How about data on demand? I think we added something to our website just recently. I'm not sure if you've already seen it. It's a very detailed data search. So you can just browse through our database. You can filter for regions, for chemicals, for processes, and so on, and basically pick the data that you need. And we are happy to provide it in the software for the software that you're interested in. And here, prices for commercial licenses, they start at 300 euros. Get cheaper if you get sets for more products. Educational licenses, again, 50% off. And this is our data on demand. So now I talked a lot. We would like to speak with you. We want to hear your questions. So let's move on to the Q&A session. And for this, I will again hand over to Mara.
Yeah. Thanks, Anna, also to you for your part of the presentation. I just have a look at the many questions that got in, and we'll just throw the first one straight to you, Anna. Your data sets are very detailed. Do you assess the error that old background data sets or not very regionalized ones are introduced as kind of like an error propagation?
Yeah. This is a good question, and I can see that you did LCA before. Because it's an important point. So what is important with our database is that we go very far upstream. So basically to the raw materials. And yes, we have backward data sets there, but the huge differences, it comes in during the chemical industry. So depending on what kind of technologies you use along the supply chain, and this is what we cover. The type and quality of the background data set, they will in turn translate into our data quality indicators. So if you look into our methodology and into the individual data sets, you will see basically a propagated quality rating for every single data set that we have. This is not stochastically or analytically propagated, but it's a rating basically based on the PEF quality indicators.
Awesome, thanks. Going on with the question to Raul now, following from an answer you already provided in the first session, if the supplier isn't in our database, is it possible to tailor it from an existing model and add in their energy consumption data?
Thanks, Mara, for reading out that question. It's a follow-up one. I think that's a very important question to highlight the power of our background modeling approach. So since we once we set up the model in the computational structure, it's relatively easy to change everything in like no time, really. So for the second part of the question, like adding energy consumption data of a particular plant, of a particular supplier in a particular country is very, very easy. If that data is available, I would love to do that directly tomorrow, because that I think is one of the major improvements we could do. The second thing is, if a supplier isn't in the database for the chemicals where we did the sophisticated modeling, I'm very sure that it will be hard to find a supplier that's not in the database, right? I'll be that optimistic. But for for other products, like a more specific one, but who's based on the raw materials for the bulk chemicals, we can easily add that supplier even with the detailed energy consumption if it's big enough. So that's very much possible. We love to extend our database together with the community and the LCA community and industry.
Yeah, awesome. Thanks for following up on that. Next question to Arne is, how do you investigate the CO2 footprints due to different energy mixes and transport ways?
Yeah. First of all, the different energy mixes, we know from the technologies that are using what the energy carriers is. It electricity? Is it steam or direct firing, or what are the feedstock resources that we have? And these are then represented based on the country-specific energy supplies for this, for the specific energy carrier. And it's similar but a bit different for transportation because it's more complex. We have a plant level model and we have a bilateral trade route. So for every single chemical and every single combination of these 190 countries in the world, we have the trade routes. So this means we have a lot of road transportation and a lot of ship transportation. And for ship transportation, we work with a partner who uses basically satellite data to track ships over the ocean. And it's funny if you see that it looks a little bit like entrails or highways along the ocean. So we get the distances for the ship transportation, if we know what the harbors are, and we do know this. And for road transportation, it's the same. We have a road service. It's not Google Maps, but with an API based on road maps, we read out the distances and then take a country-specific truck that brings the product.
Yeah, awesome. Thanks, Arne. Now the next question back to Raul is, do you have any comparison on at least one of your models and a life cycle based solely in primary data? What will be the confidence level of that data?
Thank you very much for that relatively tough question comparing databases, data sets with each other, let me start with this little internal thing we did. So what we did is we also, together with our universities we work with, is we looked at EcoInvent, Gavi, Plastics Europe, which is sort of primary data from the industry association, and us. And if you always compare EcoInvent with Gavi with Plastics Europe with EcoInvent, so you do all the cross checks and take a look at carbon emissions and fossil resource depletion, just two impact assessment methods. All databases have differences to each other between 20 and 40%. And it's not always higher or lower. It's like a complete, it's a complete normalized deviation between the data sets. So you cannot say that industry data is always lower. EcoInvent is always higher. Gavi is always lower. And carbon mines, we did the comparison with all of them as well, is exactly in the middle, like everybody is in the end. So I would say, if I would have to, I didn't do it scientifically, which I would love to, which is a little bit difficult to do. I would say the error for carbon footprints and fossil depletion is between 20 and 35% if you take all databases into account. That's at least what we did and what we can say about the accuracy of our data and the accuracy of, let's say, the LCA databases in general. And these are all state-of-the-art data sets for chemicals and plastics.
But there's also maybe something to add. The comparison was, of course, a little bit limited because we have 190 regions. Try to find a match in other databases. So for most of the data sets, it was difficult to compare value because, to our knowledge, many of them, especially on the regional level, we are the first one. Yeah.
And another, let's say, a thing we did in German, we say ein aus dem Nähkästchen. I don't know if somebody got that, but at least Mara is smiling. So we once did a comparison with an industry partner, a big chemical company somewhere in South America, and for instance, for their ethylene production, they had a carbon footprint of 1.03, and we have a carbon footprint for the exact plant of 1.04. For other products, like some that use chlorine, we had a deviation of 20% from their data set. So we do these kind of comparison with primary data with our clients, and they actually look pretty good.
Awesome, yeah. Thanks for getting so deep into this. And we just have the next question for Anne, and it's one that we just kind of summed up in one question, but it has been asked a couple of times. So what is the difference between the Carbon Mines database and the one provided by Gavi or EcoInvent, and just compare it to EcoInvent example?
I mean, it's similar to the question that we just had. I think you see the differences if you look into the methodology documents, and I don't want to make too many comparisons, but where we think that we position us, we do only chemical data. And we believe that for chemical data, we're just extremely precise. So we're the only ones who model large volume chemicals based on plant level data. And this makes a huge difference because chemical plants are clustered in integrated production sites, and the chemical plants, they don't get the average mix, they get the inputs from the plant that is located right next to this. And this is exactly what we can provide. So we can even bring it down to show the differences of the same chemical from the different suppliers. And there's often a factor 10 in between. So I think what we believe is what we're strong in is very strong technical models and extremely high level of detail. Yeah, and I think we're able to do this by concentrating really on what we are good at, which is the chemical industry.
All right, awesome. Now, next question to Rao, which will probably be a very fast question, is which data format do we provide in the data sets for the data sets?
Relatively easy, right? It's ILCD and CMA Pro CSV. That's what we are currently doing. But we can basically export if needed to any other database. It just it's a matter of time and programming effort.
Coming back to Anna, this is also a question that can be summed up by a couple of questions that have been asked in the chat, which is, do you have data from polymers, or better say compounds from the plastic industry?
Yeah. I mean, if you know the chemical industries, you know that most of the chemical industry, or very much of it, goes into polymers. So polymers, they are really well covered. So you see the different large volume polymers, or the one maybe your computer that is in front of you right now. But you also find high performance polymers, what you might find in electric devices. Looking into compounds, you have different types of materials in there, and we will often have the individual substances. So basically not the mix, the compounds itself, but you will find the matrix material, for example. So if you know how the compound is structured, you can model it based on it.
All right. So next question, I'm just picking ones that we are getting in, which are quite a lot. I'm really happy about that.
Tough job, Mara, but you're doing well.
Yeah, hard to decide which one to take. Yeah, so Raul, maybe for you, from the set of chemicals included in the database, which subsectors did you include and which did we not include apart from polymers? And what was the criteria to select these subsectors, like, for example, pesticide production or fertilizers, etc.?
So what we basically did is we started at oil and just went up the chemistry. So from the root to all the leaves. And if you basically do that, you start with oil, then you come to naphtha, LPG, ethane, propane, and all the chemical feedstocks. And then you get to ethylene, propylene, benzene, toluene, xylene. And then we basically do the production volumes of the largest chemicals, right? Petchems, and just build up the tree based on the supply chain, and took everything we got based on the data that's out on the market and in industry. For instance, since you referred to fertilizers, ammonia is in our database as well. So the largest background, urea is also included. But for some pesticides, they actually have, compared to polymers, compared to ethylene, a relatively small production volume on a global scale, which is why there's actually not so much information out there about the production location, about the production volumes, and the actual technologies that are used for these pesticides. So we basically did a sort of scientific approach based on the largest contributors to climate emissions and production volumes from the chemical industry.
Thank you. Next question to Anne is, from the data sets, can you briefly pinpoint which chemicals emitted the most and which sets of chemicals has the lowest emission per ton, for example, just to see how this looks?
Oh, wow. Yeah, that's a difficult one, I would say. It depends a little bit on where you are on the supply chain. If you want to have some rule of thumbs, the longer you go downstream, often the impact increases. So if you go into very specialized materials, for example, some really crazy additives that you might want to use in lubricant, polymer, or food applications, sometimes these are molecules which needed quite a long supply chain. So sometimes they are higher, but those are basically rules of thumbs. What is the chemical with the highest impact that we found? If we look into an impact category, to be honest, no idea. Maybe I should look it up. It would be fun.
Maybe one thing to add is where you see a large difference, like really gap between 10 to like 10 kilograms of CO2 to 40 or 50 is when you add halogen compounds to the group, like fluorinated compounds, right? Have a much higher carbon footprint, basically due to like very tiny emissions of the halogenated fluorinated hydrocarbons, which have like an immense global warming potential, right? So there you would have a gap. And also everything that's got to do with nitrous oxide, dinitrogen oxide, like adipic acid and caprolactam, rather have higher carbon footprints for the base chemicals, depending on their abatement rate of dinitrogen oxide.
All right, thank you. Next question is a little long one to read to you, Anne. How would you balance industry average versus company-specific data? Is the regionalization just based on geographical region or also company-specific? And if company-specific, how would you ensure data confidentiality?
Yeah. The short answer is it's company specific, at least for the large volume chemicals. So for basically the 78 largest chemicals, which account for more than 80% of the emissions of the chemical industry. And having this regionalization down to the supplier level is just extremely important. Let's take polypropylene as an example. If you look into the carbon footprint of polypropylene, one of the mainly used polymers, you will see that the largest contribution comes from the raw material input, from propylene. So if you took the same chemical plant and integrated together with a coal-based propylene production versus a propylene production based on light hydrocarbons, the environmental impacts are just extremely different. And if we just did the regionalization via country average processes, we would always get the mix in the countries. So it's definitely better than global average. But by going down to the company specific part, we can see, well, there's a huge, let's say, world scale polypropylene plant. We can see what plant is it integrated with, really on the level of an integrated production site. And this is often just extremely different from the regional average. And this lets us, basically calculate much more regionalized supply chains based on this plant-specific data. Confidentiality is a very good question. I think what we did here, we've modeled more than 18,000 individual plants. So it's not an option just to send emails to everyone. Usually they wouldn't give us the data. So what we used is basically the CAD secondary technical data that Raul already talked about earlier, and we combined it with market intelligence. So what company uses what process from what technology licenser? What is the production capacity, the utilization factor? And based on this information, we can understand how chemical plants are clustered in integrated production site. Exactly at this point, polypropylene versus propylene, for example, but along the entire supply chain. But this market intelligence data, this is commercially available, so it's not primary data from the companies. And by basing this largely on secondary data, we can ensure confidentiality.
Awesome. Thanks, Anna. I think looking at the clock, we have time for maybe one more question before we wrap it up. Maybe to Raul, are primary data collected in compliance to any international standard or local regulation, self-declaration and such?
That's actually a relatively difficult question because for all the primary data sets that we use, I know that they are partly based on industry reporting. To be relatively direct, the plant operators just basically tell you on their news sites where they operate, which plant, with which technology, at which capacity. It's not like they are forced to, they just want to tell because it's their technological advantage and they are saying we are the biggest on the market and they want to tell the world. So actually, let's say the data collection of that part of primary data is, I don't know if there are any regulations that they have to. I don't think so. About if we go to the emissions, right? Like Arne said, this is modeling data, and I said, right, basically said it a lot of times. So everything that's got to do with mass and energy balances is in the end modeling and simulation data that has been checked partly with our industrial partners. That's what I can say.
Awesome, thank you. All right, so just to wrap it up, yeah, thank you everyone for joining in today, for your attention and the very engaging questions. We do our homework and we'll have a look again at the questions and send some answers to you as soon as possible to also have a look at again. And please feel free to send us any further questions via mail, and we warmly also invite you to visit our website, where you will also find lots of more interesting materials about the new LCA database. And you can also get in touch, ask questions, request codes, and such things. Yeah, we hope you enjoyed the last hour and got some valuable insights, and we really appreciate you joining and wish you all a good rest of the week.
Thanks.
Thanks, everyone. Bye-bye.
Bye.